If I initially have a gas at a pressure of 12 atmospheres, a volume of 23 liters, and a temperature of 200 Kelvin, and I raise the temperature to 14 atmospheres and increase the temperature to 300 Kelvin, what is the new volume of the gas? So there's a lot going on in this problem. There's nothing that is constant, there's three different variables, and none of them are the same. So this problem must involve the use of the combined gas law. The formula for the combined gas law is P1 times V1 over T1 is equal to P2 times V2 over T2. So, first, let's identify our initial pressure. Our P1 is equal to 12 atmospheres. V1 is equal to 23 liters, and T1 is already in Kelvin, so that's just 200 K. No need to convert there, it's already in Kelvin. P2 is equal to 14 atmospheres. V1 is what we are, or V2, excuse me, is what we're solving for. And T2 is at 300 Kelvin. So now that we have everything already set up, it becomes very straightforward to answer. We're going to plug all of these terms we just defined into our equation on the left side. So let's get started with that. Be sure you carry your units. We have 12 atmospheres times 23 liters divided by 200 Kelvin. Set that equal to P2, which is 14 atmospheres, times V2 over T2, 300 Kelvin. Now it's just time for a little bit of algebra. Remember, there's two routes here. I'm only going to show you one here. You could set it up as a proportion where you multiply the top on the left side by the bottom, 300 Kelvin on the right side, and then you would do the same thing for the next side of the equation. It would be 200 Kelvin from the bottom of the left side multiplied by 14 atmospheres times V2 on the top of the right side. You can do either way. I prefer to just combine all the terms on the left and on the right and then solve for the missing variable. So I'm going to show you that route. So what we do is we multiply 12 by 23, and then you're going to divide by 200. 12 times 23 divided by 200 should give you 1.38. And notice we cannot cancel any units. So atmosphere liters divided by Kelvin is equal to 14 atmospheres divided by 300. So we're going to divide those two, and once that is done, you get 0.0467 atmospheres per Kelvin times V2. We need V2 by itself, so we're just going to divide out 0.0467 atmospheres per Kelvin. Cancel the units, cancel the numbers, like terms. Divide this side by 0.0467 atmospheres per Kelvin. And so atmospheres can cancel, Kelvin can cancel. 1.38 divided by 0.0467 will give us 29.55 liters. Is equal to our final volume. So the hardest part of this problem is probably the second step. Once you have this part of the problem defined, it's trying to figure out how we go from this to the final answer. And it's easily understandable why this would be the most confusing part. And like I said, you have two options. Set it up as a proportion, multiply the numerator of one side by the denominator of the other side, or you can do it the route that I chose, which is just combining all the terms and carrying your units until the end. Whatever way works best for you is what's going to work for me. Ultimately, I want you guys to get the right answer, and be successful with this. So I hope this video helps you better understand the combined gas law.